Hello, everyone. Welcome to another session of the DataHour series. We'll start in 5 to 10 minutes. Till then, let us get to know each other, starting from your location, that is the country from where you're joining this session. Just answer the polls. It will be very helpful for us. Thank you.
Hello.
Hello, Jayesh.
Yeah. Hello.
Hi, you're audible. We'll just wait for 5 more minutes for the audience to join, and then you can start.
Yeah. Okay. Great.
Thank you.
Just let me know. Is my screen is visible?
Yeah, after the introduction is done, we'll let you know, and then you can share your screen.
Okay.
I once again request all the attendees to take the poll and we'll be starting in 5 more minutes. Thank you. Hello, everyone. We'll just wait for 2 more minutes for any other attendees to join, and then we'll start off the session. Meanwhile, I request everyone to fill out the poll who haven't done it. Thank you. Hello, everyone, and welcome to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I'm Lakshmi Durga. With my colleague Akshay, we are a part of data science team at Analytics Vidhya and will be the moderators for this session. For those who have joined us for the first time, let me just give you a brief introduction about the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, about the session today, which is getting started with EDA tools, Numpy and Pandas. In the data hour, we'll start Numpy from scratch and discuss its famous object that is used to store data, which is arrays. And the discussion will continue with different operations and functions of Numpy. Then we'll move towards the MS Excel of Python, that is Pandas, and discuss data frames and various operations that are helpful in manipulating, creating data for ML and DL algorithms. I hope you're excited to attend this data hour on getting started with EDA tools, Numpy and Pandas with us. Before we kick things off, and I hand it over to our speaker, a quick information to all the attendees. We are recording the session and will make the recording available in a few days on our YouTube channel. Please use the Q&A session for asking any questions you might have during the session, and we'll do our best to answer them as the data progresses or towards the end. Also, we'll share a feedback poll towards the end of the session, which I request you to kindly participate in it. Now, on to our speaker in this session of the data hour, we have Mr. Jayesh with us. Jayesh is a data scientist at Siemens and also a community mentor for Python and data science for the oil and gas industry. Co-founder of Petroleum from Scratch, a venture focused on mentoring the community with core petroleum concepts as well as data analytics skills that help students as well as professionals to acquire the skills needed for Industry 4.0. Over to you, Mr. Jayesh. The virtual stage is all yours.
Hello all. I hope everybody is going good. Thank you for the introduction. So let's start the session, as it will be a hands-on session. So we will be practicing in Jupyter Notebook, and the Jupyter Notebook I think will be shared with you. I will share on the mail, as well as I will also put the Jupyter Notebook on my LinkedIn and data profile. I will provide the link in the end. So just let me know if my screen is visible to all.
Yeah, Jayesh, it's visible.
So yeah, so we will be starting with NumPy. NumPy, as the name is suggesting, stands for numerical Python, right? Nearly every scientist, not only data scientist, I'm talking, every scientist who is working in Python always uses the power of NumPy. Whether he's doing some quantum computing or machine learning and deep learning, obviously are built on these NumPy arrays concepts itself. Whether you have to do signal processing, image processing, or whatever not, nearly every scientist has once worked with the NumPy. Now, why is NumPy so famous, right? So one of the major reason is that NumPy brings the computational power of highly functional languages like C and Fortran to Python. So basically, Python is famous for its simplicity in syntax, right? And but it makes it a little bit slow language. But the NumPy library was built on the top of the code of C libraries as well as Fortran. That's why this particular library is a little bit fast. That provides us with a little bit fast computation with data. So whenever we are dealing with big data, there need to be high speed computation, right? As well as there need to be less storage when we are storing the particular data. So NumPy arrays provide that functionality to us. That's why this particular language, this particular library is famous. And also it provides multiple mathematical operations that were not initially present in the core Python. So uh, some of the people designed this particular library to solve these gaps. And after this particular library came into picture, on this library only pandas, scikit-learn, tensorflow, and pytorch, these tools were built, right? So here is an example that how NumPy is used in all the fields. So I think everybody remember this first image of black hole that the world saw, right? So for creating this particular image itself, there was a role of NumPy. One of the library that was used for creating this image, EST imaging, was based on NumPy itself. So you can see how vastly NumPy is used for all the applications. So let's do our hand dirty with the coding. So first of all, let me zoom out my screen. Zoom my screen. So first of all, we will be importing NumPy. So in this particular line of code, I am importing NumPy as NP. NP is nothing but an alias that is used for representing NumPy, because I'm not going to use the complete NumPy at each and every step. So I'm just importing this particular library. Give me a second. Let me restart my terminal. So now NumPy, one of the super power of Python, has been imported in our this particular kernel session. Now we will be discussing about NumPy arrays, the superhero of this NumPy library, the object that is used for storing data. This particular thing is up to 50 times faster than your conventional list that we use in core Python, and also takes a less space. So here, our first example will be how we can create a NumPy array from a Python list. Here, this A is our list having numbers 1, 2, 3, 4, 5. So if I want to create an array out of this list A, I just need to use np.array function, of NumPy, and I will just pass the list inside it. And I'm storing that particular thing inside an variable named array. So when I'm going to run this function, you can see it is outputting that my list A has been converted to an array that is stored in this particular variable, having 5 elements itself. Now, in a similar way, we can also convert tuples. I hope everybody knows the difference between list and tuples, because these are some of the core Python concepts itself. Just pass the tuple inside this np.array function itself, and it will automatically create that into an array. So this type we are using to see the type that, okay, the t variable is of type tuple and arr variable is of my type numpy nd array. Now here nd, you can see there is this nd. So this particular nd represents n dimensions. So array can be a 0-dimensional array, 1-dimensional array, 2-dimensional, you can also say as matrix, 3-dimensional, little bit one dimension higher than the matrix, where matrix will be its unit In this way, there can be n-dimensional arrays present, right? And these particular n-dimensional arrays are itself used in higher applications of your deep learning or machine learning itself, right? If you guys know, there is this particular LSTM cell when we talk about NLP or time series forecasting. So that LSTM cell takes data in 3 dimensions. So basically, we use tensors there, but tensors are also nothing but array itself. Just the name is different. If we are using TensorFlow or PyTorch, their name is tensor. If we are using NumPy, their name is array. So if you know what is going beside a deep learning algorithm, you can design your library yourself by using NumPy. So let's start with this ND array or dimensions in array. So first of all, we will discuss about zero-dimensional array. Array having only one element. If one element is present inside an array, that is zero-dimensional element. You can also correlate it with the coordinate geometry. If we talk about x and y plane, if we are just pointing a point somewhere in the plane, so that is one point, right? Only one point is present. So that you can say that, okay, that is zero-dimensional array. It's just for correlating with the coordinate geometry. So here you can see in my np.array, I just passed one number inside it, 45, and showing that in ARR. So when I'm going to check the dimension of this particular array, there is this attribute dot ndim for checking the dimension of NumPy array. So when I'm going to hit this cell, you can see 0 here. So it is representing that, okay, it is a zero-dimensional array, right? And when I'm going to call this ARR, you can see array 45. Now, if I try to enter another number here in itself, so it is going to throw me an error because zero-dimensional array only can only have one element. So when I entered 54 here, it is going to throw me an error. So how to create one-dimensional array? We'll see that. Now, again, if I join these zero-dimensional elements together, if I join the points on the coordinate geometry together, I will get a straight line. And that particular straight line or that particular array of all these joining zero-dimensional array is my one-dimensional array. So basically, the one-dimensional array will have these 0D arrays as its basic elements, common elements. And this is the most common and basic array that we use. So for creating one-dimensional array, you need to pass a list or tuple inside this np.array. For example, here pass the tuple inside it. So here you can see my dimension has become 1. You can also pass a list instead of tuple. So that will also be created. So in this way, you can use one-dimensional array. Now, again, imagine we have a straight line. Now let's join a number of straight lines, right? So that will make you a square or rectangle, right? In a similar way, when I'm going to join these one-dimensional arrays, we can create our two-dimensional arrays. So you also know them as matrix, right? So these 2D arrays have these 1D arrays as its elements. And how to create 2D array? Here you can see np.array. I'm using 2 dimensions here. One dimension is this, right? This one-dimensional element that we have seen earlier. And the second dimension is this, the outer square bracket, right? So if I show you here, this array is having 2 square brackets, right? So by looking at the number of square brackets itself, you can know that which dimensional array we are talking about. So 2 square brackets basically means 2D array. So one dimension is your this side. You can say this column side. So when I go towards this particular direction, you can say it is made up of these one-dimensional elements itself, right? So this one-dimensional element was the 1D array that we were talking about, and the other dimension was added of the rows. So in this way, your two-dimensional arrays are created. And again, when I will run ndim, you will be able to see 2 dimension here. There is other function in NumPy also named as np.mat that can be used for creating the matrix, but that is no different only. We generally use np.array itself, right? Now, as earlier I said, most of the machine learning or deep learning algorithm works on are nothing but a couple of linear algebraic operation itself. And NumPy provides me that functionality with different functions. One of the example I will show you here. Here I have made a 2-dimensional array A2D. having these elements. Let's first see a 2D here. So this is my two-dimensional array here. You can see, or you can also see say that it is a matrix. Now, if I want to calculate the A inverse or matrix inverse of this particular matrix, NumPy provides a function for that also. You can just use np.linear algebra, linalg dot inverse, and inside that inverse, just pass your matrix. And in a couple of seconds, not a couple of milliseconds, it will give you result of inverse of your matrix that you are providing it. So just like this, there are many more linear algebraic functions present. You can just see that by just writing this in linear algebra and press dot and press tab. So here you can see, you can find the determinant, eigenvalues, eigenvectors, all these things you can find by using this particular linear algebra module of NumPy. Right. Now coming to our 3D arrays. Now we are going to combine the squares or the 2D arrays and stack them together. That will result into a cube, right? And that cube is my three-dimensional array. So basically, now in this three-dimensional array, the 2D array behave as a small element gathering which the 3D array is created. Here you can see when I'm creating a 3D array, again, three square brackets are there, right? One dimension is your this particular dimension, the 1D array that we initially talked about. Second dimension is your this one element of this particular 3D array, right? And third dimension will itself be complete array. Let me show this ARR first. So here you can see. Yeah. Here you can see three square brackets are there, representing that okay, it is a 3D array there. Now this 3D array is nothing but build up of two-dimensional arrays. One this two-dimensional array and the second this two-dimensional array. And when we go inside this particular two-dimensional array, you can see that this two-dimensional array is nothing but build up of two one-dimensional array. So in this way, arrays are interpolate in Python. So in this way, high-dimensional arrays can also be created. And there is one other NDMIN argument present inside your np.array function, in which you can just pass that, okay, which what dimension of array do you want? For example, I'm creating here a 5-dimensional array. I've just passed some numbers here, but I have mentioned that I want this particular numbers in a 5-dimensional array. And when I'm going to hit this particular cell ARR, you can see 5 square brackets are there. And when I'm going to see ARR.ndim, you will be able to see 5. That it is showing that 5-dimensional array has been created. Now coming to the next part, shape, or checking the shape. So shape basically tells you how many number of elements are present in a one particular dimension of your array. So for example, this is my 2-dimensional array, right? ARR. I see here. So when I'm going to run ARR.shape, it is going to throw me 2 cross 3 because you can see 2 rows are present and 3 columns are present. Or in other way, if you want to see 2 is representing how many total number of one-dimensional arrays are present inside my this 2-dimensional array. So basically 2 one-dimensional arrays are present, one this particular one and the second this particular one. And 3 is representing how many 0-dimensional arrays elements are present inside my these one-dimensional arrays that are sub part of 2D array. So basically 3 0-dimensional array points are present, right? So shape will give you number of elements across each dimension. Now let's discuss some of the inbuilt methods for generating arrays. For example, in core Python, if you know, there is this range function by which we can generate numbers. Similarly, in NumPy, there is a range. Only one A is added here. So the syntax for generating the arrays is just pass the starting point, the points at which you want to start your array, the stopping point, and the step size. At what step size you want. For example, in this particular array, I am passing that okay, I want an array starting from -10, stops at 10 with a step size of 0.5. So you can see started from -10, then a step size of 0.5, which means -9.5, then -9, -8.5, and it will go on to till 9.5. Just remember this one thing, that when we are using range function for generating arrays, the stopping point is not included in the array. So if you see stopping point, I mentioned 10, that 10 is not present here. We have just generated till 9.5 itself, right? Now I'm going to use the pos function that is present inside NumPy itself for finding the pos value of this particular array. I'm storing that y equal to np.pos pos array. Now, if we are going to see the plot of this particular function, matplotlib is basically your plotting library that is used for creating the plots out of the data. So from that plotting library, I am using plot function, and on the x-axis, my this array values will be there, and on the y-axis, their pos value will be there. So if you see here, you can see a beautiful pos curve, right? So in this way, this is the one way of generating numbers by using NumPy array function. Another function that you can also use is linspace. So it basically creates linearly spaced arrays. That's why its name is linspace, right? So here, what is the syntax? The syntax for the first two things will remain same, that we have to pass the starting point and the stopping point. Here, instead of step size, you have to pass that how many total number of points you need in your array. So, for example, I am creating an array here starting from -10 to 10, having 10 points, right? And one difference between this linspace, the other difference between this linspace and arrange is that in arrange, your stopping point is not included. But in linspace, if you see the array here, stopping point is included, right? So this is also one of the difference. So now if I'm going to plot the sign graph of this particular array, you can see here it is kind of having edges because I have just used 10 points. If I increase the total number of points, let's take them 100. So this particular graph will be smoothed, right? So now coming to the array indexing part, we have created array, we have generated array. Now if I want to assess any element from that array, how to assess that, right? It is similar to the list indexing that we use in Python. Our index will start from 0. So for example, this is my NumPy array 1, 2, 123, 45, 67, all, and these all things. So this particular element, first element is present at 0th index. In MATLAB, your indexes starts from 1, but in Python, your indexes starts from 0. So when I'm going to pass here, for example, if I want to assess this first element, this one here, I just need to write the name of the array, square bracket, and inside that just pass the index at which I want the value to return. So I want at the first. So here you can see this one is returned. Now the thing is that inside the array I also passed strings here. If you see, all is there, last is there, right? So all the elements that are present inside my array will automatically be converted into strings. That's why when I'm seeing the type of 0th element, it is returning me numpy.string. Now if I remove the string parts and let's just take integers, so here you can see that string has been converted to integer 32. Venkat is asking, sir, for statistical modeling. We will be taking the answers after the live, after the class, right? So now, again, if I'm indexing this particular thing, you can see the strings or the quotes have been removed from this particular one. Now this will not be working because only 4 elements are present, means only 3 indexes are present. So if I'm going to hit this, it will throw me an error, index error, that index is out of the bound. Now, as there are positive indexes, from the backward, negative indexes also starts. So for example, this is present as 0th index, first index, second index, third index. And there is a negative indexing also. The last number will be present as at my -1 index. This will be at -2, this will be at -3, and this will be at -4. So if I'm going to hit this array -1, it is going to return me 67. So in this way, you can index any elements out of an array. Now, if I want to assess multiple elements, Then array slicing comes into picture. As the name is suggesting, slicing. So we are cutting the slice out of the array, right? So big array is present, big numpy array is present, and we have to cut the slice out of that. How to do that? We'll see. Again, here syntax will be more like np.range itself. If you see that I know an particular array, this ARR is an array. Let's see here. This is an array, and I want to get a value of first 5 elements, right? So I have to pass the starting index of the element of which I want to start the slicing, the stopping index of my slice, and the step size, right? So here I am passing that, okay, my starting index is 0, my stopping index is 5, and step size I haven't mentioned, so automatically it will take step size as 1. So when I'm going to return when I'm going to hit this, I will get first 5 elements. And again, the stopping index is not included in this slicing function. Because if you see, only 5 elements are there starting from 0, 1, 2, 3, 4. So stopping index was my 5, that was not included, right? In a similar way, here I have mentioned step size as 2 because starting and stopping I'm not mentioning. So Python will automatically understand that we have to start from the 0th element, we have to go till the last element, and step size is 2. So I will get alternate values, right? Here you can see alternate values are there from this particular original array. And also you can use negative indexing also, as well as negative step size. So basically in positive step size, we move from left to right. In negative step size, we are going to move right to left. So here I'm trying to inverse my array, right? Here, if you see, I have provided that my starting index or starting point will be -1, means my starting point will be this particular element, right? Stopping point I haven't mentioned. And after that, I am mentioning that my step size will be -1. So it will understand that it has to go from right to left. So here you can see itself that my array has been reversed. In a similar way, if I want a reverse array with alternate value, instead of -1, I have passed -2 here. So reverse array with alternate value. In this way, you can take the slice out of your one-dimensional array. For higher dimensional array, same thing will be there. For example, this is my two-dimensional array. First of all, we will be talking about indexing, right? This is my 2D array. So here I want to get this 5 out of this particular array. So its index will be given by 1 and 1. How? In this axis or in this dimension, this this 5 is present at first index, right? Let me write on the screen, then it will be easier. So here, if I give the indexes here, so first of all, we will be talking about this particular dimension. So this will be 0th index. This particular first one-dimensional array will be present at 0th index. This is present at first index. This is present at second index, and this is at third index. Now entering the lower dimension means my one dimension, right? This will be at 0th index, first index, second index. So in this way, if I see the address of my 5 will be 1, 1, and the address of 8 will be 2, 1. So I am just passing AR 1, 1. It is returning me 5. If I pass 2, 1, it is going to return me 8. And again, here negative indexes, again, we can use in higher dimension itself. So if I write negative indexes for this particular thing, this will be at -1, -2, -3, and -4. Similar way, -1, -2, and -3. So you can use both the method, positive or negative index, for assessing any elements out of your higher dimensional array. So in this way, from the two-dimensional array, you can index out an element. Similar thing will be done for three-dimensional array. Just the thing is that the new three-dimensional, was present there. New dimension will be present there, your third dimension. So for example, here, if we again see this particular array, that is my 3D array, right? If I see this particular 3D array, it is composed of two-dimensional arrays, right? First is this two-dimensional array, and this second is this two-dimensional array. So this first one will be present at 0th index, second one will be present at first index. Now going to the lower dimension, which is my 2 dimensions, right? So here in this particular 2-dimensional array, this 1-dimensional array, this 1, 2, 3 will be present at 0th dimension, and 2, 3, 4 will be present at first index, right? And again, going into the 0-dimensional space, 0, 1, 2. So in this way, again, you can access any particular element. So for example, here I'm assessing this particular 3 out of this array. So this 3 is present in the in this 2-dimensional space that is at 0th index. So okay, I have entered that my first dimension will be 0, or the first index from the higher dimension will be 0. And when I entered this 2-dimensional space, now this 3 is present in this second row, right? Which means the second 1-dimensional element, right? So second 1-dimensional element, if I see the index, that will be 1, because index starts from 0. So I mentioned here 1. And again, in this particular row, again, it will be at first index, second element. So in this way, you can index from higher dimensional arrays. Now, the same thing will be done for slicing itself. The start, stop, and step size, as we seen in 1-dimensional array, the same thing will be done for higher dimensional. The thing is that only commas will be there for each dimension itself. So for example, this is my 2-dimensional array. I am here indexing, I am here slicing, starting from this particular row that is present at first index, going till last with a step size of 2. So I am just slicing this row and this row, right? So I have sliced in 1 dimension. Now if I want to slice in both dimension, so this particular row has been sliced, or this particular 2D array has been sliced. Now I also want to slice in column wise also. So here I am passing that my starting index will be 2, which means this particular column, 6 and 67. And I have to go till last 5, right? With a step size of 2, means it is going to skip this 732 and will be taking this 853. Right? So the similar way was used as we were using in 1-dimensional array. The only thing is that for the different dimension, we have to mention different slicing technique that we want to use, or slicing indexes that we want to use. In this way, you can take the slice out of it. Now, if I want to reverse, this particular cell, here I'm reversing it on row wise session. So if you see, my last row has come to the first row in the below one, because I'm mentioning that okay, my starting point is -1, my step size is also -1. So my 2D space has been reversed here. Now, if I do the same thing for this particular thing, you can see that my complete array has been reversed, because 5 was present here, that has came here. 21 was present here, that has came here. So in this way, slicing can be used. Similarly, for a higher dimensional also, you just need to pass the slice for each dimension, and you will be able to get that slice out of the higher dimensional array, right? Now moving on to the next thing, our reshape. Shape, as I mentioned earlier, shape is nothing but number of elements present in each dimension. So here again, if I see this particular example, shape is 2 cross 4, basically meaning that it is a 2-dimensional. First of all, it is a 2-dimensional array. How do I know from this particular shape? Because only two elements are present in array.shape, right? So giving number of elements in each dimension. So in the first dimension, it is 2, and 2 number of elements are present, which means that 2 1-dimensional elements are present, and 4 is representing that 4 0-dimensional elements are present, right? Same thing can be done for higher dimensional thing also. For example, this is my 3-dimensional array. So it is showing that 3 2-dimensional elements are present in this 3D array, and inside those 2-dimensional arrays, 2 1-dimensional are present, and all those things, right? I hope this shape thing is clear to all. Right? Now reshape comes into picture. So we have an array, this particular array. Let's say this A is there, right? Let's first of all see this A also. This A is there, 1-dimensional array, right? Because in shape itself, you can see only one element is present. Now I want to, as I said earlier, in LSTM or in convolutional neural network itself, three-dimensional tensors goes inside that, right? Or in LSTM, if I take an example of time series forecasting, I will be getting time series data in one-dimensional form, right? But in one-dimensional or two-dimensional form, right? But my LSTM cell takes input of three-dimensional elements, right? So I have to reshape that two-dimension into three-dimension, right? So for doing that, reshape function comes into picture. So here you see this A is there. Now 24 elements are present inside this A, and I want to reshape it into a two-dimensional array of shape 6 cross 4, means having 6 rows and 4 columns. So I just can use A dot reshape, and inside that just pass the shape of my choice that I want. So here I have passed 6 cross 4 inside this reshape. And when I'm going to see this A to 2D, you can see two-dimensional array has been created from your one-dimensional array, right? And if you see the shape of it, it is 6 cross 4 dimension. In a similar way, you can also reshape into higher values. For example, here I am reshaping this one-dimensional array itself into five-dimensional array system of this particular given shape, right? So if I run this, you can see we have reshaped it. But can we reshape into any shape, into any particular shape, right? So in while using this reshape function, one requirement or one necessity need to be fulfilled. That is in the in the starting, or you can say in the initial array. Here you can see 24 elements are there, and in the final array, number of elements need to be same. So if I am reshaping A into some shape, I need to take care of that particular thing. So I have reshaped into 6 rows 4, right? Total number of elements are 24, 6 into 4, 24, right? Now, if this condition is not satisfied, that will throw us an error. For example, I am here trying to reshape that A array into 7 cross 3, means 21 elements. So I cannot reshape 24 elements into 21, right? So that one condition need to be satisfied. Everything else NumPy will handle. Now comes unknown dimension thing in reshape itself. Now there can be a chance that you have to reshape your low dimension or a high dimension arrays into some different shape, but you don't know number of elements in one particular dimension, right? For example, let's see this example here. This is my A having shape 24. Now I want to reshape it in such a way that it have one row, right? But I don't know how, let's assume that I don't know, or I am not able to calculate that how many total number of columns need to be present when I'm just reshaping it into a one row, right? So you can just pass that unknown dimension as -1, and Python or your NumPy will automatically calculate the number of elements in that unknown dimension, right? So here it has automatically converted my array into 1 cross 24 shape. In a similar way, you can pass that -1 in any dimension, in any particular dimension. For example, here the same 24 element I'm reshaping, and I know that 3 rows need to be present, but I don't know how many columns will be there. I will just pass -1 for the column shape, and Python has automatically calculated that okay, 8 columns will be present, and reshape my array into 3 cross 8, right? And again, if I pass here 5 and -1, it will throw me an error because your 24 is not divided by 5, right? And that total number of elements condition is not satisfying here. That's why it will throw an error. Here again, I'm trying some high dimensional arrays. I've passed that, okay, for the 3-dimensional array, first dimension, I don't know. The other 2 dimension are 2 cross 3. So it has automatically generated me 4 cross 2 cross 3 array here, right? So that was your unknown dimension. Now coming on to random number generation powers of NumPy. Now there can be scenario actually in as I come from oil and gas industry. So there is kind of lack of data. So if we have to perform some data science project there, or if some student is learning data science there is not that much of data. So this particular random number generation has helped me a lot during my initial days when I was learning data science. So NumPy provides some of the modules through which you can generate random numbers. one of the example here is randint. So if you want to generate a random integer, inside NumPy there is this module random, and inside that there is this function randint that you can use. Here, for example, in this particular cell, I'm just using np.random.randint. I am providing my minimum value and maximum value. And when I'm going to run this particular cell, it is going to return me a random number in between 50 to 100 every time. And every time I run this particular cell, the random number will change. Now, in this random itself, if I pass the shape of array that I want, for example, I have passed here 4 cross 3. So a 4 cross 3 array will be generated. Here you can see of random numbers, random integer numbers. In this way, you can generate random integer arrays of different shape. Now, if I want to generate random float number, between floats are basically your numbers between 0 to 1 decimal points. For that, inside this random module itself, this .rand function is present. Here, this one. So every time I hit this particular cell, it is going to return me a number between 0 and 1, right? And here again, you just need to directly, because we are getting the numbers between 0 and 1, so I need not to pass the minimum value or maximum value. I just need to pass the shape that I want of my array. So here, as I have mentioned 5, so it is going to return me one-dimensional array having 5 elements. Here I have mentioned 5 cross 4. So 5 cross 4 array of random float numbers is generated here. Other function is choice. So in choice, what happens? It kind of generate random values based on the values that we have provided it. For example, here, if you see, I have provided a list of numbers here, 43, 56, 76, 89. Now this choice will only generate number from these 4 numbers and randomly each time. So for example, 76 is generated, 43 is generated, 89 is generated, 76 is generated. In this way, this will generate a random value based on array of values that we are providing it. And again, you can pass the size here also. For example, I pass 3 cross 5. And so basically, there can be scenario that you know particular feature of of the data, right? You want to generate a data, and you know that this particular data can only take these values. So by using those values, you can generate a random data structure out of that, or random data frame out of that. You can also pass the probability for each value also. For example, here 4 values are present, 3, 5, 7, 9. So there is this, there is this input P, inside which you can pass the probability for each values, each values, right? So I'm passing that probability of getting 3 is 1 and all other is 0. The sum of all probability number need to be equal to 1. So when I'm going to hit this particular, and also I have passed the size here and generating this array and generating this array. Now when I'm going to see this X, you can see that it is filled of 3 only. And if I pass 0.5 and 0.5. Okay. There I passed the size thing also. So you can see only 9 and 3 are present now, right? With a probability of 0.5. In this way, you can also specify the probability for each value in this choice function. Right now, coming to other type of random number generation, that these random numbers that we discussed, random number generation, that doesn't follow any probability distribution except this choice. In choice, we have mentioned that okay, this will have this probability or not. Now there are some of the numbers or some of the distributions, data distributions that follow some of the probability distributions, right? So we can also generate random numbers from those data distributions. Right. One of the example of this distribution is normal distribution. So in normal distribution, your data distribution curves look like this, right? This particular thing, the peak is your mean, and this sigma is representing your standard deviation. So basically, this mean is representing your central tendency of the data, that your central, most of the points are lying here, and how much spread is your data around the mean is represented by this sigma standard deviation. So these type of data distribution, you can also generate random numbers following these type of data generation. You can also generate. For example, I want to generate a random distribution having this random numbers having this normal distribution, having a mean of 10 and the standard deviation of 5 and total number of 5,000, total number of points 10,000, right? And I'm also generating other distribution y having mean 5, standard deviation 10, and points again 10,000, right? So I'm generating this x and y. And now if I'm going to see the distribution plots of these x and y distribution, okay, I won't import it keyboard here. So here you are going to see the distribution plot here. So this particular blue one is my x, because you can see we have mentioned mean as 10. So it is kind of having the mean at this particular point. And also spread of this x is less as compared to this y, orange one, right? So this was your normal distribution, and in this way you can generate a random numbers following normal distribution. There is this standard normal distribution also. In this is all this particular thing is just like normal distribution. The main difference is that your mean becomes 0 and your standard deviation becomes 1 here, right? So for that, there is this np.random.normal. By default, it will be generating your standard distribution. Then comes uniform distribution. Here, probability of getting every number or each outcome in the number will be same. So for example, one of the example is when I throw a dice, probability of getting 1, 2, 3, 4, 5, 6, any number will be same, right? 1 by 6. So those distribution comes into uniform distribution. Again, you can also create uniform distribution by using numpy np.random, and inside that random module, there is this uniform function present. Just pass your minimum value, maximum value, and total number of points here. So here, if I see the histogram plot, kind of we are getting a uniform distribution, right? So as this particular number going to increase, you will get more closer to your uniform distribution itself. So in this way, you can generate your uniform distribution. And then this uniform distribution type of thing you can also generate by using choice, right? As I mentioned, we can also pass the probability inside the choice. So for example, I am here taking these 10 numbers and I am passing that probability of getting each of the number is 0.1, 0.1, 0.1, all of them having same probability. And when I am running this cell and plotting the histogram plot, you can see kind of similar, right? Kind of uniform distribution. And there is this binomial distribution also, that again data for that can also be generated by using this numpy random function. Now we will be discussing about some of the functions, trigonometric, algebraic, and all those functions in a brief that numpy provides. One of the great example of arithmetic function is addition. So for example, when we talk about two lists, for example, here I have mentioned two lists, A and B. Now, if I want to add the element of these lists, it's not that simple. I need to write a for loop in zip and all those things, right? Because if I just enter A plus B, it will give me a concatenation of these two lists, A and B. It is not going to give me a list that is a result of addition of elements, right? So it is going to give me a concatenated list. Now numpy solves this particular function. So if we apply this particular thing is also known as vectorization. So if we apply a particular operation on a numpy array, that will be applied on all the elements that are present inside that array, right? So here what I have done, I have converted my A and B list into arrays, array A and array B. And when I'm adding them, ARA plus ARB, you can see that element-wise addition has taken place here. 4 plus 1 is 5. You can see 5 here at the first index. So this particular thing also has an advantage of using numpy arrays over list. Similar things for your multiplication also, your division also, and your exponential powers also. Same thing as the addition, right? So this is my array A, array B. Now, here, what was the thing that both number of elements in array A and array B were same. Both were having five elements, right? That's why all the operations were taking place. Now I created another array ARD that is having 3 elements. Now, if I'm going to run this operation on the arrays having different number of elements, it is going to throw me an error, value error. It is showing that operands could not broadcast together with the shape of 5 and 3. One is having shape of 5, other is having 3. So NumPy is not able to broadcast the values on different shapes, right? This A was list. Here I was just showing you exponential power thing also. For example, here I will perform the same exponential example on the array. You can see on every element present inside that the array, this particular operation has been applied. Multiplication thing we have seen. Now this absolute, if we want to get the absolute values from array or list, some anything, this np.abs function is there for getting the absolute values. np.square root function is there for calculating the square root of the values. Just need to pass the data structure or object inside it, and it will get give you the result of square root at each element, right? Now, one more thing that NumPy introduced. So in your core Python, here if you see, A was your list, right? So when I'm going to use A divided by 0, it is going to throw me an error, right? That unsupported operand list will not be divided by 0. Now, if I'm going to use ARA divided by 0, it is going to return me an element infinity. So in NumPy, this infinity element is present. So if we are performing any operation using NumPy, and there was a chance that there is division by 0. So instead of throwing an error and breaking your complete pipeline, it is going to give you that this infinity solution there, so that your pipeline will be in place, all the operation will be taken place, but you will know that, okay, in some where inside my pipeline, I have divided by 0. So this is one of the advantage, so that complete pipeline is not broken because of this division by 0, right? In this np.infinity object is present inside NumPy. In a similar way, np.nan, that is not a number or not an integer. That thing is also present inside my NumPy. Now, if I have two arrays, array A and array B, and if I want to take the dot product basically means summation of product of each elements. So 4 will be multiplied by 1, 5 will be multiplied by 2, 6 will be multiplied by 3, and so on. And all those numbers will be added. That particular thing is known as dot product, if you remember from your high school. So for calculating the dot product, this dot function is present. Here I'm just using array dot array B, and it is giving me dot product of array and array B. In a similar way, you can also make the transpose of your matrix. For example, this is my two-dimensional matrix, ARE. I want to see the transpose of this thing. I can just write ARE.T. This is my transpose of this particular two-dimensional matrix. In a similar, and then comes min-max, minimum value, maximum value, average value, and standard deviation of a given array. So this is an particular array ARD, right? If I want to know the minimum value present inside this array, you just need to write the name of array, and after that write dot min. It will give you minimum value. Dot max will give you maximum value. Dot argmin will give you the index of your minimum value. So this minus 110 is present at 9th index in this array. Argmax will give you index of maximum value, right? ARD.sort will sort your this particular array in an ascending order. So if you see this starting from minus 110 and increasing till 556, in this way your array is sorted. ARD.mean will give you the mean of these values or average of these values of the array. ARD.standard STD will give you standard deviation of your particular data distribution. So these are some of the statistical functions of NumPy that you can perform on given data, right? Now, rounding function is also there. These are some of the functions that we are just discussing. So, for example, we have this particular array, right? And I want to round off all the elements inside it till 4 decimal points. So I can just use ar.round, and mention 4, means the number of decimal points till which I want to round off the array elements. So here you can see this 0.4 as it was already having 1 decimal point, so need not to round off till 4. But these particular higher decimal values, or you can say having more decimal points, have been round off to 4 decimal points. This 1.565677 was there, it was round off to till 4 decimal points. Again, you can also use np.round also. In np.round, the first element will be your data that you want to round off. The second element will be your number of decimal points till which you want to round off. Right? Your floor function is used when you want to round to the nearest lower integer. So when I use np.floor, here you can see 0.4 was there, right? So nearest lower integer to 0.4 was 0. So it has rounded it to 0. 0.89. Now it will round off to your nearest lower integer. So again 0.89, 0 is there, so round it to 0. 1.89, or if you see here it was 88.9. So when I use np.floor, it will round off to lower value. So it has rounded it 88.9 to 88. And np.seal, as the name is suggesting, seal upper value. So it will round off to upper value. So this 0.4 was rounded off to 1. 88.9 is also rounded off to 89. Minus 1.5 is rounded off to minus 1. Trigonometric function, as we earlier saw when we plotted the graph, it also provides trigonometric function for calculating the sign of a particular value, right? np.pi, when I'm calculating, it is getting me somewhat 0 itself, 10 raised to power minus 16. np.sin is there, right? np.cos is there. np.degrees basically convert your pi value or your radian value into degrees. np.arcsine, basically your inverse trigonometric functions are there. Radian to degree values are there, right? So in this way, there are different trigonometric functions also. np.hip is used for calculating the value of your hypotenuse when base and perpendicular values are given using Pythagoras theorem, right? And similarly, it also provides some of the logarithmic and exponential functions also. So np.exponential will get me e to the power 1. Exponential, if I pass 2 here, it will return me e to the power 2. In a similar way, if I pass a list here, so it will calculate the value of e to the power at each of the element present inside that particular list. Log is a logarithmic function is also there. You can also find the value of your ln e, or you can say log base e, right? So log base e, log base e 1 equal to 0, and log base e of e is itself 1. Log base 10 is also there, np.log 10. So you can also do these operations also by using NumPy. Last operation from the NumPy is matrix multiplication. So if we have two matrices, right, in this one, one of the matrix is this, having shape 2 cross 4. Other matrix is this, having shape 4 cross 2. So one condition that need to be satisfied for matrix multiplication is that, for example, if I have two matrices A and B, A is of shape m cross n, then B need to be of shape n cross j. So basically, total number of columns that are present inside my A matrix need to be equal to total number of rows that are present inside my B matrix. Only then we can do the matrix multiplication, right? So here, if you see, my AR is of shape 2 cross 4, ART of shape 4 cross 2. So this particular 4 is matching this. So I can calculate the matrix multiplication of these both arrays. And the final shape will be equal to this cross this. Now, this was all about NumPy. Our next thing is Pandas. So we'll be, as time is less, so we'll be discussing it in brief, and there may be a chance that we can come up with the next class of this particular session itself. So basically, Pandas is your Excel of Python. Till now, we have talked about arrays and how to use those arrays for some of the linear algebraic function and all those things, right? But in data science, data word is there, right? So we need to read that particular data. So if we talk about tabular data, basically present in CSV or Excel files or tables, So for those can be read or loaded in Python by using pandas, right? And this pandas library itself is built on the top of NumPy, right? And the full form of this pandas is panel data. And before pandas, Python was just used for data munging and preparation. There was very little scope of using Python for data analysis or data science. After coming of this pandas itself, this Python has become so famous in data analytics field. Now these pandas can be used for loading your data to the Python, preparing the data for your final machine learning algorithm or model, right? Manipulating the data, that if there some null values are present or unnecessary values are present or outliers are present. So all those manipulation you can do by using pandas. Modeling the data. So basically you can also modeling and analyze the data by plotting using pandas plotting itself. So again, first step will be importing the pandas. Here alias of the pandas is PD generally. So I'm importing pandas as PD. Now if I want to read a CSV file that is present inside my system itself, there is this read CSV function that is present, pd.read CSV, and inside that just pass the path of that particular CSV file. So here in my system, this tips.csv is present at a particular path. I pass the path inside this read CSV function and storing that particular data frame inside a df, right? So when I'm going to call this df, you are able to see a table-like of thing, right? Now this table-like of thing is superhero of pandas. This is data frame. In NumPy, superhero of NumPy was arrays. In pandas, superhero of pandas is this data frame, right? Now, some of the function, if you want to see first 5 or first few rows of the data frame itself, you can use df.head. That will by default return you first 5 rows of your data frame. And if you mention here some number, for example, I mentioned here 2, so it will return me first 2 rows of my data frame. df.tail for returning last 5 numbers of my data frame. Again, if I mention here 3, so it is going to return me last 3 rows of my data frame. As I have read CSV in a similar way, we can also read Excel files by using pd.read Excel. And again, here I have to pass the path of my Excel file, right? And in the Excel file, if you guys all know that there can be different sheets, right? But by default, this read Excel file will read the first sheet out of that particular Excel. But if you want to read any other sheet, then you need to mention the sheet name here. That okay, in this Excel file there are different sheets. I mentioned that sheet name is department. So here, when I'm going to run this particular cell, it has read that particular sheet only. You can also read the data from HTML or websites itself. For example, this is a website of NBA or basketball players, right? So pandas provide this function read HTML, and inside that you can just pass the website where some of the tables are present, right? So in this basketball reference website, there are this table of different NBA players is present. So that it has also read. But here you can see there is a change. There is a little bit change in the format. Here we were seeing tables, but here this particular thing it has read as list, because there is a chance that in a given HTML link there can be multiple number of tables, right? So this read HTML will read all the tables and store them as a data frame inside a list. Now, if I index this particular list, 0th index, if I see, you can see first table has been arrived here. In this way, you can use pandas for reading different. So our reading and loading part ends here. Now let's load this Titanic data set. I hope you all guys know. Just give me 1 minute, guys. Just give me 1 minute. So here I'm loading this Titanic data set that is present inside some of the GitHub repository of someone, right? So by using read HTML, I'm reading this particular data set. Now, if you see this df here, you will be able to see that, okay, it is in list format. First of all, I want to get the data frame out of it. So I'm indexing the first element from that particular list. That is my nothing but the data frame of our Titanic data set itself. So now you can see here, There are 891 rows and 13 columns, different columns. Now let's come to some of the function of pandas. df.info, as the name is suggesting, information. It provides the information about each of the columns, right? Different name of the columns and how many known null values are there. So by looking at this particular thing itself, you can know that how many null values are present inside your data frame. So I can see here that in this age column, 714 known null values are there. Means some of the null values are present because all of others are having 891 known null values. And here in cabin, only 204 known null values are there, right? So in this way, you can see, you can get a basic idea. And also you will get an idea of data type. For example, passenger ID is integer type. My name is object type. Obviously, it is a string. Again, sex is also object type. Age is float type, means 14.5, or in this decimal values, age is present there. So this info provides information, basic information. Next come my describe function. Describe basically provides me statistical values of my data, statistical value of my data frame. So here you can see in df.describe, it is providing me count from each cell, from each column, how many total number of nominal values are present, what is the mean of these particular things. For example, what is the mean of age? 29.69 was the mean of the age of passengers that were traveling in Titanic. What is the standard deviation? You can see that. What is the minimum value? So minimum value of the age was 0.42. What is the 25 percentile of my data, 50 percentile of my data, 75 percentile of my data, and what is the maximum value of the data? The maximum, if you see, is age is 80 here. So in this way, describe function can be used for knowing the statistics of your data frame. df.column basically returns me the list of my name of columns of my given data frame, right? Now here, if you see this unnamed column is present unnecessary, I want to drop this particular column, right? So you can drop this column by using df.drop. Inside that, just pass the name of column that you want to drop. Pass the axis. Axis basically means by default axis is 0. That means it will drop the rows. But when I have set axis equal to 1, it will Python will automatically understand that I have to drop this particular column, right? So after seeing the axis is equal to 1, it will run inside the columns and match the unnamed 0 and drop that there. And in place 2, I'm mentioning that, okay, I don't want this unnamed present in my df itself, right? So when I'm going to use this cell and see df here, you see that unnamed column has been dropped. In this way, you can drop any number of columns as well as rows. If you want to drop the rows, just mention the index of the rows inside this df.drop and pass x is equal to 0, right? If you want to drop the columns, pass the names of the columns and pass x is equal to 1. In this way, you can drop the data from your data frame. Now, if I want to extract, this is my data frame df, right? If I want to extract one column out of it, any one column, for example, I want to extract the name out of it. So I can just use df square brackets, pass the name of the column that I want to extract and run that particular cell. So here you can see it has returned me a series of the names. Now, if I want to extract more than one element, more than one column, in that scenario, I have to use 2 square brackets instead of ones. And when we use 2 square brackets instead of a series, a data frame is returned. Again, if here itself I use 2 square brackets, you see output of this particular single square bracket was series. But when I use 2 square brackets, outcome will become a data frame itself, right? In this way, you can access different columns out of your data frame. Now, if you want to know how many null values are present or how many visualize the null values, you can use df.isArray. It will basically return you a boolean true. The points that are true here you can see are representing where null values is present, right? So in cabin column at 888 index, null value is present. False is representing where no null values are present. Now this is kind of not looking nice, right? I want to visualize it. So I can visualize this by using heat map itself. I just need to pass this df.isArray in the heat map of seaborne. And here you can see the white points are corresponding to 1, basically corresponding to true. Black points are corresponding to 0, basically corresponding to false. So white points are representing the null values. So here I can see that age is having null values. Scattered cabin is having a lot of null values. And then Bart is having null values somewhat here. And you can handle these null values by different method. One is dropping the null values that I generally don't prefer because I don't want to lose my data. And other methods are interpolation by using different interpolation techniques. Spline interpolation is there, mean interpolation is there, but that again, that particular thing is again itself 1 hour session itself. So we are not going into that. So here, if I'm going to use df dot is the na dot sum, it will return me that how many null values are present inside each column. So in H, 177 null values are present, cabin 687 null values are present. Now comes somewhat of conditional data framing. So for example, here I'm using np.where. So if I want to know the indexes values where my age column is having null value. So here, how I can do that? I'm just using np.where that will return me the index values, right? And inside that I'm passing this particular condition that df of age means df of age column is null, and that is equal to true, right? That particular condition I have passed inside my np.where, and it will return me the indexes of the rows at which my age column is corresponding to null values. In a similar way, you can get the complete data frame out of that thing. For example, if I show you here, so df age is null is equal to true. It is returning me this Boolean type of structure that is just telling me that where age value is present or not. When this particular thing is true, it means that null value is there. Now this condition, this particular condition that is returning me a Boolean structure. I have passed that particular condition inside my data frame itself by using square brackets, right? So it will return me only these 2 points, or the points where my age is nan or age is null value. So in this way, you can pass any of your condition. For example, I want to know what is the maximum fare of my ticket. So you can pass that particular condition inside this df square brackets, and the Python will return you that particular data frame only, or that those particular data points only, right? In this way, conditional data framing can be used. And guys, all these topics kind of require more time, but we are covering all this in 1 hour session. That's why I think it is a little bit fast, but no need to worry. I will be sharing this notebook with you guys. I'll give you the link for this particular notebook. iLog. Now this iLog function comes into picture. Now, if I want to get the value of a particular row, then I can use df.ilog, and ilog and log, two different things are there. When I need to pass an integer location, I need to get an integer location. For example, I want to get the second row or third row. In that scenario, I will use ilog, df.ilog, right? But when I want to know the complete row corresponding to a given index, so for example, if you see this particular data frame, this Titanic data frame, your index is your row number itself, right? But there can be a chance, there can be a scenario that in some of your data frame, you have to use some different index. For example, I'm changing this index to name, right? And if now you see data frame here, your index has been changed to name, right? Now from ilog, you can get directly the integer value, or you can directly get the rows corresponding to the given integer. For example, here I'm using df.ilog 0. I'm getting the first row out of it, having name. But if I know a name of a particular guy, and my data frame is having index as a name, and I want to know the information about that guy, I need to use log there. So log will give you the information depending on your index name. So here, for example, I mentioned blonde. I want to know about Mr. Owen. I'm using df.log and passing this here. And I got to know that he's a male of 22 years old, and he was not able to survive in the Titanic crash. In this way, you can get ilog as well as log. Again, if you use two square brackets with ilog, it will be return your data frame kind of structure. And when we were using when we were using only one square bracket, it was a series type of an output. Now, the thing that I was mentioning here, for example, I want to extract the record where fare was maximum. How I can do that? So see this particular cell of code. I have mentioned the condition here that np.fare df fare is maximum of df fare. This particular thing is calculating the maximum fare. That what was the maximum fare present. And that I'm passing inside np.where that will return me index value, and that I'm passing in df.ilog. So it will return me the names of the people or the complete information of the people, those who have paid maximum values. Now for getting the unique values from a column, this dot unique function is there. For example, from embark, I want to know the unique values. You can calculate that. For getting the values, the value counts for a categorical feature, this value counts function is there. How many males are present, how many females were present, right? And you can also plot this particular male and female graph by using count plot of seaborn. You can visualize. So in this way, you can use different function itself. Now, if you want to create the data from the pd.data frame function itself, I'm using some random numbers here that we discussed earlier. I'm creating random I'm using. So I'm basically creating random decimal points of shape 5 cross 5. So this pd.dataFrame function is there for creating a data frame out of some of the data that you have. Just pass that data at the first as first argument. After that, I am passing that what will be the name of my indexes, and after that, I am passing the column names here. In this way, you can create your own data frame or your own table out of it. So if we see df1 having column names as column 1, 2, 3, 4, 5, indexes as A, B, C, D, and these are the random numbers that are created by random, right? And now if I want to add a new column here, that is kind of sum of column 1 and column 2. Basically, now I'm doing data manipulation here, right? I'm adding new column or new data. So you can just add new column by creating a new variable having name of data frame and passing the name of the new column here. And after that, just do any mathematical operation or anything that you want to do. For example, here I'm adding first and second row. This new column has been added. But if I also want to multiply it by 3, so you can see in this way, you can add new column inside your data frame. Now, dropping null values. As I said, null values can be dropped or interpolated, but we are not going in that interpolation section here because again, that will require a lot of time. So this was my data frame, right? So I want to drop the values. So I can just use df.drop. Inside that, I am just passing that where my age is null. Drop that particular thing. It has given me error because I need to reset the index. Storage silent. Now I'm using df.drop because np.where kind of returns me indexes number, right? And I have, as you remember earlier, I have set it index as name. That's why that was showing error. Here I have resetted my index again. Now from np.where I will get the indexes number, and from df.drop I will drop those particular indexes. In this way, your you can drop depending on any condition. But if you want to drop all the null values present inside all the columns have all the rows having null values inside your data frame, you can just use df.drop any, and that will also drop all the rows having null values. You can also kind of drop the column itself because, for example, in one of the column only 200 non-null values are there, so you can also drop that particular column itself. Now comes join and merge. if two data frames are present, how to join them or merge them, two different functions, right? So I'm creating two data frame, df1 and df2. Both are having a same column key. So I can merge these both data frames depending on this key itself. So if I use pd.merge, pass df1 and df2 inside that, and on function I am passing that on key index, I have to on key column I have to merge them. So it will return me a merge of df1 and df2. Join, similar to merge, but only difference is that on key column is not present here. It will directly merge your data frames. For again example, df1 and df2 were there. I'm just using df1 dot join df2, so it has joined the df2 ahead of df1. In this way, you can do merging and joining also. Sort values you can also do. For example, here I'm sorting the data frame depending on the value of pair, right? So here you can see maximum fair, minimum fair to maximum fair. And now the final thing is plotting, inbuilt plotting. I'm just showing one plot here. You can plot the complete data frame by using df.plot. Subplots I'm keeping as true so that each column has been plotted in different figure. And after that, I'm just passing the figure size. So here you can see, we can see the plots of ages. We can see the plot of survived or not survived. We can see the plot of fair. So these were the some of the basics of Numpy and Pandas. That's from my side. So any doubts? Let's see. I'll provide the Jupyter notebook and I will also be sharing it on LinkedIn. So I'm providing the LinkedIn profile as well as my GitHub profile so that you can get the Jupyter notebook from there. I hope you guys enjoyed the session. I tried to explain from scratch itself. And if you want to, I also, as said earlier, I also run an tech social type of startup, petroleum from scratch. Basically, we have a YouTube channel. So there also we have a complete, all these complete things, Numpy, Pandas, Matplotlib from scratch itself. So if you want to see the videos, you can also subscribe to that. Also, I'm also mentioning the channel link. Thank you to all. Let's see question answer.
Sorry to interrupt you, Jaish, but there is a small announcement for all the attendees. Before we proceed to answer your questions, I would like to request the attendees to kindly fill in the poll about feedback as it helps us to conduct more such sessions. Thank you. You can carry on, Jaish.
Yeah. Ravinathan, it is possible negative indexing and positive indexing same. Yeah, it is possible. Let's see. Let's show you an example here. So this ARR my array, right? So I'm using 0. So for example, I'm doing slicing here, right? So let's slice. I want starting from 0, minus 1, minus 2, minus 3, right? I'm writing starting point in my negative indexing and stopping point in my positive indexing. 0, 1, 2, 3. Let's pass as 3. So here you can see. Let's pass as minus 3. What is the benefit of having non-broken pipe when having inference data in infinity? So what is the scenario when we are designing a complete pipeline for a data science project that is going to be deployed somewhere, right? And if it is throwing error somewhere, that will kind of interrupt your whole production server itself. So we handle those errors in some different methods. For example, we use try and accept and all those things. So there need not to be some error. Those need to be handled. In logs, those things will come. That's why Infinity is kind of np.inf is kind of a good addition in NumPy. Guys, just instead of chat section, write your queries in Q&A. Starting, are we getting slides? Yeah, the better note will be shared. Can you help to understand interpolating Python? Yeah, I mentioned that again. Itself is a different topic itself, interpolation. But yeah, on LinkedIn, I kind of try to share things. So maybe we can connect there and see the things. How does R compare to Python? Thanks. Both of them have different syntaxes, but you can use both for doing a particular thing. I prefer Python more because I'm more I like it more than R. Can you explain slicing array a bit more? So basically, in slicing, we provide starting point, stopping point, and step size. Nothing else. I will be sharing this notebook. Just play around this notebook, and you'll be able to answer itself. Does this dimensionality related to row or column picture in matrix theory? No, I don't know, Naga, about your question. ILOC and log. Basically, ILOC is, as the name is suggesting, integer I corresponding to integer. So when I know that which number of row I want to see, I use ILOC. But when I know which index I want to see, then I use log. Okay, Madhu? How to read XML file with pandas. Basically, XML files are basically used by CV2. So I have never used pandas to read XML files. Explain on slicing with 3D array. Okay, many of you are saying slicing for 3D array. Yeah, I will be explaining that again. Before that, Vitor has asked np.range and np.linspace. So in np.range, we pass step size, right? That how much step size I want between between different elements of that array. And in np.linspace, we pass number of elements. For example, there can be two scenarios, right? One scenario is that you want to create a data where you know that you have to create a data with the step size of 2. You only want even numbers, right? So in that scenario, you have to use np.arrange. And the other case is that you know how many total number of points you need. In that scenario, you have to use np.linspace, right? Hmm. A difference between this plot and this plot. This again we will be discussing if we go on to the second session. Complete visualization we will be discussing. How do you utilize these libraries function in any real life example? Whenever you are going to do a end-to-end data science project, for example, you get a your first step is you get a data from your client or whomever, right? So you need to know about your data, right? You need to play with your data. And there is this one saying by me, the more you sweat during EDA stage, means knowing your data stage, the less you will bleed while you're modeling part when you are playing with machine learning algorithms or deep learning algorithms. Please suggest any good book for EDA. So there is this one book of Pandas by O'Reilly. You can refer that. 3D slicing, I will be going again. Okay, so please share your LinkedIn profile in the chat. Okay, I have shared already. I'll be sharing again. So here you go. And notebook you will be finding. I've shared my GitHub profile, right? So in my GitHub profile, I will be creating one repository here itself. Let me share that particular repository link itself. And I will be putting. So you will be able to find the notebook here. I will be uploading the notebook here in this particular thing. I've shared the link. Are you guys not able to see my link? Okay. Host and panelist it has set. Wait a second, man. Everyone. Okay. I'm sharing it again. I have set to everyone. I'm sharing it again. So these are the link for my YouTube channel, my GitHub repo, and my LinkedIn profile that I have shared. Now I think you will be able to see the links, and the next link will be where I will be uploading the Jupyter notebook itself. Now are you able to see the link?
Yeah, Jayesh, we are able to see the links and they'll be probably shared with the YouTube video that would be uploaded.
Okay, great. Now the last thing, slicing with 3D array. So let's visualize that. Yes, my 3D array. So okay, this is my 3D array here, right? Let me grab my pen once. So this is my 3D array, right? So I want to slice the data out of it. So here, if you see this particular line of code, this is representing, first of all, let's index through each dimension. So this will be my 0th index. This will be my first index. This will be my second index. This is for the third dimension, right? Third dimension. Now let's go inside some lower dimension, right? This 2 dimension, let's go inside, right? So this will be my 0th index. This will be my first index. Now let's go inside 1 dimension. This will be my 0th index, first index, second index. Similarly for these elements also 0, 1, 0, 1. Now, if you see here, what I am saying that in my third dimension, I want the arrays starting from 1 and stopping at 3. So basically, I want these two arrays, these two dimensional arrays, right? Now let's go inside 1 dimension, right? And I am mentioning that I want in this particular 2 dimensions, I want my arrays at first index itself. So basically, I want these 2 lines only. Now let's go inside them again. Now I am again mentioning starting point 1, stopping point 3. So basically these 2 points means these 2 points. So it is going to return me 78, 23 and 67, 45. Right? If you see here 78, 23, 67, 45. Now I hope it is clear to all. Do you have files to null value handling? You can find that at TDS. Do you have any notebooks where you implemented interpolation? Yeah, I have a notebook where I used interpolation. If you go to my GitHub repo, you will find in one of my repo. Let me see which repo was that. In this particular predictive maintenance repo, you will be able to find the notebook. In that notebook, I have done interpolation. Notebook not available in the folder. I haven't uploaded yet. I will upload after the session. Give me 5 to 10 minutes. I will upload that notebook. Let me upload it. I will share the notebook itself. And no need to worry, I will also be uploading on PDF on LinkedIn also. So you can also connect with me there if some of you are not able to use GitHub. So any other doubts? I think all the doubts are clear. Why 1, 2, 3 as the second and third element? It should give second to fourth. No, because 3 stopping point is not included, right? So it will only give you array that is present at element that is present at first index and second index. That is your second and third element. That's why it doesn't given second to fourth. Can we use log function for 2 different columns? Yeah, you can use for 2 different columns. By log function, that will give you the complete row. And from that row, you can kind of get the column values by using indexing. It will take some time for uploading. Let's hit upload and I will share the link. And then I think we are good to go.
Hi, Jayesh. With the time constraint, I guess you have answered most of the questions that you would be doing in this session. And thanks a lot on behalf of Analytics Vidhya. I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. Thank you so much, Mr. Jayesh, for your valuable time.
Thank you so much. Okay, guys, I will be uploading that there itself on the link that I have provided. You will be able to download. It is uploading. And thank you, guys. You are a great audience. It was a great time. Happy learning. Have a great day ahead. And if you have any doubt, we can connect on the LinkedIn regarding anything. Have a great day. Bye.